What do we need to find? After we have the function, we have to find
X to find Y.
After we have the function, what is the next step?
Oh, we have to differentiate.
Exactly. So d prime, I didn't mean that, d prime AO of x will be, can anyone differentiate this function for us? Anyone, please?
Wouldn't it be 1/2 times the square root of the function? Times the inner function prime.
Very good.
So 10x plus 12.
Excellent. So this cannot be 0 because if it's 0, the distance is 0. So d prime of x cannot be undefined. There is nothing. But it could be 0. If it is 0, then if it is 0, then what?
It would have to be 0.
Yes, 10x plus 12 has to be 0, or 10x equals negative 12, or x equals negative 1.2. Does this give a minimum? I have no idea. I will in a minute. I refuse to study the sign of a square root. There is nothing to study. It's always positive. So when I plug in here negative 10, when I plug in 0 to the side, the right-hand side, this is definitely a minimum distance. No question about it. What is it? I have to plug it in. So I have d of negative 1.2 will be the square root of 5 times 1.2, negative or positive, it doesn't matter because it's squared, minus 12 times 1.2 and plus 9. The square root, what is my square root? Right here, of 5 times 1.2 squared, and then minus 12 times 1.2 and plus 9. So the minimum distance is approximately 1.34. Now they're really asking us to find the point. Okay, no problem. So then the point A, will have x negative 1.2. But now we have to determine the y value. No biggie. Because when x is negative 1.2, so y equals 2 times negative 1.2, negative 2.4, and plus 3. And that is 1.6. 3 minus 2. Oh! 3 minus 2.4 is 0.6. So where is the point? So the point is 0.6. So the point is somewhere here at negative 1.2, 0.6. So this is the correct. So this is the correct point. And the coordinates of the point, negative 1.2 times, comma, 0.6. Remember, the point has to verify this. So 2 times negative 1.2 will be negative 2.4. Negative 2.4 plus 3 will be 0.6. So we determine the point whose distance on the line, whose distance from the origin is the absolute minimum. No other point on this line has the minimum distance from the origin, but this one. Any questions? And what is the distance? 1.34 approximately. Any questions on this? Any questions, please? Any questions?
Can we do another one that's like a line like that?
Yeah, so we can go and look at the ones with the poster, for example, if that's what you meant. So the top and bottom margins of a poster are each 6 centimeters, and the side margins are each 1. So top and bottom 6, 4. So not 1, 4. Sorry. If the area of the printed material on the poster is fixed at 384 centimeters squared, find the dimensions of the poster with the smallest area. Is that okay? And that's my page 11. Is that okay, everyone?
Yes.
Okay, so let's look at 41. So we have a poster. We are told that the printed area was 384 square centimeters. Got it? And they're saying 6 centimeters here, 6 centimeters here, and 4 centimeters to the side. To the sides. I'm going to read it again. The top and bottom margins, okay, 6. Side margins, 4. If the area of the printed material on the poster is fixed, find the dimensions of the poster with the smallest area. So the dimensions of the poster, x times y, the area is x times y. We want to minimize this. Knowing that this is fixed, we don't know the length and the width. Knowing that these are our restrictions. So the printed area is this, margins, respectively. We want to find x and y to minimize area. What area? This. Okay. So we know that this is x. How much is this? From here till here.
X minus 8.
Exactly. Awesome. Great job. Excellent. And now, of course, we want this piece. This piece.
y minus 12.
Exactly. Perfect. So I know that this area, this is given to us as 384. But this must equal base times height. What is the base? X minus 8. What is the height? Y minus 12. Okay, so then I will distribute
Is that, I'm sorry, is that 389 or is that 384?
384. Oh,
Right?
I don't know.
384?
I don't know.
That's what I had written down originally.
Yes, 384. I think I'm okay on that one. I have 384. Do you see a mistake that I don't? It's possible.
No, the 4 in the image looked like a 4, but then compared to what you had in your equation, that looked more like a 9. So I was just confirming that it was.
Sorry. Good. Good. So then I will distribute 384 equals xy minus 12x minus 8y plus 96. And then I will get I am thinking that it would have been better to denote this by x and this by x plus 8, but let's stick with what we have because it should give us the same thing. Doesn't matter. The notation is not important. It may have been slightly easier if we had denoted this by x and this by y, but that's okay. Okay, so then we have xy. I'm gonna move, what do I want to do here? I know that this is the area, the x times y. So do I want to do that? So that's our A. So if the area, when I move everything to the other side, so I have 384 minus 96 plus 12x and plus 8y equals x times y, which is the area in question. So the area is 12x plus 8y, and I will subtract 96 from 384. So plus, I have an 8, right? Yes, and then I have an 8 again, and then I have 288. So the area again has two variables in it. So we have to be able to remove one of the other, or the other. So let's see how we do that. Once we remove x or y, preferably y, but it doesn't matter. We can rename them, or we can still have a function of y, right? It doesn't matter. So let's see how we remove one of the two variables. And once we do that, then we can find the minimum or the maximum. Of course, we expect the minimum, but we can draw conclusions till we study the sign of the derivative. Okay, so let's see how we do that. We are told here that we don't have any other information. So we just have that x times y is the area in question. We have the 384 as being x minus y and y minus x minus 8 and y minus 12. So if I had denoted from the very beginning the inside with x times y, that would have been easier because then the length would have been x plus 8 and the width would have been y plus 12. And then the area would have been x plus 8 times y minus 12, and I would have replaced x and y. But I still have the same situation. I still have to eliminate one or the other. It doesn't matter. So I don't see any big advantage or disadvantage. Okay, so when we solve, let's say y minus 12, that will be 384 divided by x minus 8. So then y will be 384 over x minus 8 and plus 12. We also know, so then y in here, I don't like, well, I have no choice, but I didn't really like all these calculations, but it is what it is. It is what it is. So that's all we are given. Let's just make sure.
I'm sorry, can you go back?
Yes, so that's all we have. If the printed area material of the poster is yes, find the dimension of the poster with the smallest area. That's all we have. There is nothing else. Okay, perfect.
So
Yes.
With the other questions, we didn't plug in.
With all the other questions,
I'm thinking of the one with the.
Yeah, with all the other questions, all we had to do is eliminate one of the.
Like the one where it was the volume was the 10 meters cubed. We didn't use that until towards the end. Are we supposed to save that?
But no. I already have a formula for the area. I'm already done with this step. See, we had the total cost, and now I had to use this to eliminate h. So it's the same. All steps are the same. I still have to use what I'm given, and the only thing I'm given is this, that x minus 8 times y minus 12 is 384. From here, I have to eliminate y. So when I solve for y minus 12, I have 384 over x minus 8. When I solve for this, 384 over x minus 8. And now I have to add 12. So I found an expression for y. And this expression for y has to replace this y. Is that clear? I have no other choice. This option, it could have been a little bit easier to calculate eventually, but it's the same idea. So it doesn't matter. I don't want to confuse you.